Welcome back again. In this lesson, we will show how we can solving problems that containing distance and displacement. But first, remember what is the distance and when we can determine the displacement. Okay, the difference between them that the distance doesn't need the directions. We start from point A to point B. So we doesn't need the direction to determine the distance. But the value of the displacement, it must contain the directions. So we have four main directions. We have the north and south, east and west. The first case we can solve, the object move from point A to point B, or from the starting point to end position. This is the value of the distance. What about the displacement? In this case, the displacement value equal the distance value equal the value of AB, or the length of AB. Okay. What about if this object return back from point B to the starting point again? In this case, we have the distance equal the value of AB twice or double, because this is the actually length of the object movement. So the length of the distance equals, for example, it moved from A to B for 50 meters. So it returned back. So the value of distance equal 50 meters plus 50 meters equal 100 meters. What about the displacement value? The displacement value in this case equals 0. Why? Because it returned back to the final position again, so we doesn't have the displacement. What about another case? We have an object move in curved line from point A to point B. The distance equal the length of the curved line, and the displacement equal the shortest length of movement for this object from A to B, or from the starting to the end position. So the shortest length between the 2 points equal the value of the displacement. This is the imaginary line we can draw between the point and another point. This is a new kind of problems. We have a rubber pole fall downward from a height equal 2 meters from the ground, then return it upward 1 meter, then fall down again to rest on the ground. So calculate the distance and displacement. Okay, the distance, it's the actual length that the rubber pole move from downward to upward to downward one more time. So the distance values equal 2 meters down plus 1 meter up plus 1 meter again downward to the ground equals 4 meters. What about the displacement? Remember, the displacement equals the shortest distance, or the shortest value equals, yes, 2 meters down. Another problem, we have a car starting motion from point A and covers 30 meters northward to the point B within 30 seconds, then 60 meters eastward to point C within 20 seconds, and also then 30 meters southward to point D within 10 seconds. Then it's a stop. First of all, we will start to get the given. So from this figure, we will get the given. First, D1 equals 30 meters. T1 equals 30 seconds. D2 equals 60 meters. T2 equals 20 seconds. D3 equals 30 meters. T3 equals 10 seconds. What about the length from D to A? To complete the drawing, it's like the imaginary doesn't apply or mention inside the problem. So it's considered as the shortest length between the starting point and the end position. So it's the displacement. Okay, he asked to get or find out the total distance. We will add the summation of only the distance that is mentioned inside the problem. So the distance that is mentioned inside the problem, it's considered as the distance inside the problem, or the actually length of the distance. So the summation equal, or the total distance equal, D1 plus D2 plus D3 equals 30 plus 60 plus 30 equal 120 meters. Number 2, he asked about the number or the total number of the times that mentioned inside the problem, of course. Also, the times are 30 plus 20 plus 10 equals 60 seconds. Okay, the third thing that asked about in this problem is the displacement. We mentioned before the displacement in this case equals the length between the D to A. So it's the shortest imaginary line between the starting point and the ending point D. Equal the value of the AD equals 60, that is equal to the parallel BC.